Hello there. This problem recently came up as the last problem on a Math Team Geometry event, which is normally the hardest type of problem. I liked it because it applies directly to what we're doing right now with similar triangles in 3x. So let's label our givens here. I suppose the angles are already labeled for us. Okay, so we're trying to figure out the perimeter of this whole big triangle ABC, which means we need to know this length and this length. Now, this would be helpful if there were some similar triangles involved, and there are. These angles are going to match up right here, and we could look at the sides, see if there are any proportions there, but that's not looking all that promising. This angle here is going to be what unlocks it all. So we got that angle over there, and now we have this triangle here with the red angle and the green angle. And then we have this larger triangle down here with the red angle and the green angle. So the first one is triangle ABD. I'm going to be a little bit easy on myself. I'm choosing a direction for this where I'm going red angle to green angle, ABD. And that's going to be similar to the other triangle. And that order going from red angle to green angle is ACB. So I'm listing those out, and that's true by angle, angle. And then what you can do is you can list out all of those proportions. So doing the first ones, AB over AC, AB over AC, that's got to equal the second ones, BD over CB, and that's got to equal the last ones, AD over AB. And the reason for that was corresponding sides of similar triangles are proportional. We often don't need to list that stuff. We're just doing this as a numerical problem. And then we can start putting in the values. That we know that AD is 40. Actually, I suppose let's start up here. AB. We don't know what AB is. I find it a little bit confusing when we have multiple letters, so I'm going to call this one the left, and I'll call this one the right. So AB, that's the left, over AC, that's that whole distance on bottom, that's 50. That's equal to BD, which we know is 30, over CB, that's the right-hand side, and AD, that's 40, over AB, that's the left-hand side. So all these things are equal. Now if I just look at any two of them, like these two here, that's too many variables, left and right. I'm not sure about that. But if I look at this one and this one, there's only one variable. So I can write that part out. And multiplying through, I'm going to get that L squared equals 4 times 5 is 20, and then there's a couple more zeros. So L is going to be the square root of 2,000, which is also 100 times 20. And the square root of 100 is 10, and the square root of 20 is 4 times 5, so that's 2 root 5. So L is 20 square roots of 5. Okay, so now that we know L, we should be able to get R. Alright, so I'm substituting in on these first two over here, and I can already do some reduction. Maybe I multiply through by R, and then divide on the other side. So this is going up here, that's going up there, this is coming down over there. And we could multiply this all out. There's some cancellation that we can do. Like we can cancel, what can we cancel? We can cancel these two, both divisible by 10. So we get 2 and 5. And then on the top, and then the 2 and the 30 will reduce to 15. So we got 5 times 15, that's 75 over root 5. Which we'll want to rationalize. I think this one was a little bit shorter last time I did it. Maybe I had a different arrangement for the fractions. 75 over 5 reduces to 15, so that's 15 root 5. So what we have is over on the left-hand side, that's 20 root 5. Over on the right-hand side, that's 15 root 5. So the perimeter of the whole thing is going to be 20 root 5 plus 15 root 5 plus the bottom length of 50, or altogether 50 plus 35 square roots of 5 in exact form. Okay, so this one, it's quite difficult to sort of visually start thinking that you got this triangle here, the pink one, and it's being reflected and sort of shifted a little bit onto this purple one, so which sides are matching up with which. But if you write out the similarity here, where you're saying, okay, red angle to green angle, and a red angle to green angle down here, and get those triangles. And now those triangles, the path that you wrote them in, tell you which way to set up all the proportions, and then you can make your substitutions, and at that point it's just an algebra problem. And you don't need to think about how this 50 on this side is being reflected over and scaled, or not the 50, this length on this side is being reflected and scaled up to the 50 and solved there. And it's news break time. Character and Scholarship for Life.